Hi guys, it's Cliff here. I can't really say hello again, it's Cliff here from down under. It's just getting a bit predictable, isn't it? So howdy folks, episode 26 of RapidTurn. I thought I might put this ahead of episode 25 because I struck a bit of an issue with the conversational software, and I'm not sure if it's a fault with the software or just my interpretation of it. But in case there's somebody else with a similar interpretation, I might put it out early ahead of 25 just in order to save crash. Yeah, I'm doing so many of these videos lately and I'm really enjoying them too. There seems to be about once a week, and so this one could be ahead of 25. Cheers. Seems to be a fault with the conversational on the OD turn, but I might be wrong about this. This is not my area of expertise. I can't believe something this obvious has been overlooked. You know, if I set up an OD turning situation where it's going in 0.6 deep, so there's a series of cuts from 20 millimeters down to 16 millimeters, and I've got a 0.2 finishing depth of cut. So it should go in 5.8, come out back down, another cut, a millimeter deeper, 5.8, another cut, 5.8, 5.8, up, and then come along to the 6 millimeters and come down. Facing cut, finishing cut. But what's happening, I'll show you the program in a second, is that it's going 5.8, 5.8, 5.8, 6. So the whole tool is taking a full facing cut, and that's crazy dangerous. Am I missing something here? I'll show you the program. Okay, so here's the code. So we're going a cut of 18.2 diameter, going in a Z to minus 5.8, back out. Second pass down to a cut of 16.4 diameter, to a Z of minus 5.8, back out. And the finish pass, where we should be coming into the 5.8 again, it's going to a cut of 16 millimeters, that's the 0.2 cut, and it's going all the way to 6 millimeters, that's slamming into full depth. I mean, if that was more than just 2 or 3 passes, that could be a real major crunch up. Then it's coming back out. Now it's doing a facing cut to the 6 millimeter depth, but it's too late. It's already slammed into full Z travel. Am I missing something? I can't believe something that obvious has been overlooked. So please post and let me know, guys. Let's see if I can explain it another way. So here's a part. We're doing an OD conversational turning. Here's our finishing and roughing cuts. So the way the conversational works, unless I'm doing something wrong, is that it takes the roughing cut to there, pass 1, pass 2, pass 3, however many there are, and on the finishing pass it goes the whole way, which would cause a huge cut right at the end of the depth of the finishing pass, and then comes back in like that. Now, I might be doing something wrong, or there might be a fault with the software. There's another alternative. I've just been thinking about it, and it may be just a difference of machining strategy. So the Tormach PathPilot conversational software designer might have been thinking about a different machining strategy. I might have been thinking about a tool shaped more like that. So you would take cut 1, cut 2, and then finally when you come to the finishing pass, because it's on such a steep angle, it can more comfortably go in the whole depth of the finishing cut. If it was aluminium or acetal or something soft, you could almost get away with that and then come back in for the finishing cut, or come back in. Does it back off like that? I'm not sure. But if there was enough side clearance, you might get away with that. But you know, normally you want to have that the turning tool's leading edge without too much clearance. It wants to be almost in line with the part, so that it's cutting with better geometry, and that type of tool clearance situation would cause a massive cut right at the end. And so I would question the strategy if that was their intention. Well, I hope you're not wanting to watch just videos on RapidTurn, because it's sort of morphing into a mixture of RapidTurn and odd tips and tricks and me uncluttering my cluttered mind. Well, that's it, the end of the run. And look at it, Swarth City. Oh dear, have I got a clean up job on my hands. Oh well, I better clean it up now, because the next job could be acetal or something in it. Don't mix. Well, it's a good thing I didn't film, it's a good thing I didn't video that wash down cleanup operation. Would have been a comedy act. I was halfway through washing down with this wash down gun, and the fitting on the end broke off at the worst possible moment, and I got washed down more than the machine did. My God, that was a disaster. Anyway, got a temporary fix on that. Occurred to me is a couple of things that might be of interest to some of you guys. I know I've gone on about this before in other videos, but underneath the Y-axis covers here, you've got the ball screw sitting there, beautifully ground precision ball screw exposed, and you really don't want abrasive particles getting that may be partially dissolved or in a slurry with the coolant getting down on top of that ball screw. So I put some thick grease on the joint there between the covers at each end to act as a bit of a barrier to keep the coolant from dripping down and taking the grit and stuff down on top of the ball screw, because that could, if it ended up on top of the ball screw, could very quickly scour and wear out your precision Y-axis movement. So it's a real case of prevention is better than cure. Another thing that didn't occur to me for many years is that if you've got a hearth brush and pan or whatever you call it, and use it to sweep the concrete floor around your bench grinder and the concrete dust and all that stuff, you get all that dust sticking on the hairs of your brush. And it's just occurred to me a couple of years ago, well, don't use that brush to clean down your machine, because what you're doing is applying abrasive grit onto your machine, which then dissolves in the cutting oil and then ends up in slideways, bearings, ball screws. So just have a brush that's used for cleaning your machine down. It doesn't get involved in dust and abrasive grit. And I think it's a really good idea to have a strong cotton cover over here. And what I've recently found is if you have a couple of long wires, you can push them in to the last little grooves in the bellows covers, here and here, like that, and that holds them. That holds the cotton cover taut and helps to filter and deflect a lot of the abrasive particles and swarth, and also stops it from getting in between the bellows, so that when the Y-axis has gone back that way, it's less likely to crunch up and split the bellows and cause problems. So there's several benefits with having a top layer on there and holding it down with a couple of wires or small diameter rods. Alright. You've probably already thought of this one, but in case you haven't, it's a good idea to have a piece of clean synthetic cloth and just put it on top of a gauze filter. I'm going to make a mess of this. It's all going to go pear-shaped, and then just dump that, so that what you're doing is actually filtering the cutting oil as it's coming through each time and helping to extend the life of the cutting oil and the condition of the cutting oil. What are your thoughts on corrosion control? Here in New Zealand, I'm up high on the hill and we're facing the south, which is Antarctica, and sometimes we get the bad combination of cold and damp, and suddenly you can get corrosion on steel and cast iron surfaces. And so I've been using WD-40, and recently I've been reading that Inox MX3 is even better. So I just put a trace of that on, and I've not actually had any problems in the last couple of months since I've been using a trace of that. It seems to stay liquid. If you've got any thoughts about this subject, send me a comment under the YouTube channel or forum post. I'm keen to get the best, most efficient way of controlling corrosion. It's really good to have an opportunity when you work alone to think out loud. And I think a lot of you guys possibly come from a background like me where you've got a manual lathe and a CNC mill, and you're considering getting into CNC turning, but you haven't yet got into it. And so I'm kind of discovering the advantages of CNC turning, of a CNC lathe, especially recently in a repeat production run situation. So you might find some of this next part of the video of interest. Cheers. With these ITTP arbors, there's two internal diameters. See if I can show it to you here. And there's a face down there, and that face is an end stop for the impact tolerant retract mechanism to contact. And it would be a nice refinement if that face was skimmed and undercut slightly. It would give a even bigger margin, design margin or factor of safety. And so one of the advantages of CNC that I hadn't fully recognized previously is that you can build up through a cumulative process an increasingly sophisticated program that you wouldn't normally do with manual turning. It couldn't manually face all of those little faces down there. It would just take up too much time and add to the cost of the product. But with CNC, you can do a little additional refinement program and just append that to the file of the NC code, and that for the next production run, it's just added in a little automatic process that doesn't take up any more of your time. So through a sort of a cumulative evolutionary process, you're able to increasingly refine the production process with each following production run. So I can produce a little bit of code, can modify it with a bit of hand coding if need be, pop a little boring bar in there, and I'll just run that now. And as simple as that, you've done a complicated little procedure, faced and undercut down inside of ore. Bit difficult to focus on that. Anyway, next time I run these, I can just add that little bit of code and that tool position to the gang tooling platform. The advantage of this type of gang tooling platform is that you've got a lot more area to mount tools. If you think of it as an inverted U shape, so that you can still use the tailstock in the middle, you can have the TTS type holders on either side of the inverted U and other ordinary type tools on the horizontal portion. You've got much more capacity for holding tools than you have on a conventional CNC lathe that just has one axis of movement, the X axis. Here you have an X and a Y axis, which gives you a whole area of many times more capacity for different tools. I'm not trying to say that RapidTurn is superior than Slant Pro or any other CNC lathe. Obviously it's inferior in a lot of ways, but there are one or two advantages to RapidTurn that we should be aware of. So just to reiterate that point, one of the advantages of CNC production, repeat production runs, that I hadn't fully realized is that you can build increasingly sophisticated and refined programs which take care of themselves in regard to the amount of work that is done, because they run automatically. So you can, with a small amount of work, refine the program increasingly, and with each production run benefit from it in a way that you just can't do with manual machining. So for example, that little machining operation, it's got its own file name, arbor face bore, and then the next time we do the production run, we append that to the main file, and it's from then on permanently installed in the main program. So it's a sort of a iterative, cumulative, evolutionary process. I know I'm sounding very philosophical and abstract here and rambling on. I'm not sure if I'm getting my point across 100%. What really appeals to me is that you're building the intellectual property up in the programs in a way that you can never do with manual production, where you just have to put in long hours of donkey work. But with computer control production, repeat production runs, you can just progress. I've been thinking a lot about this question, do we need a CNC lathe in our shop? And one way I've been thinking about it is there's three distinctly different types of work. There's the tricky, the tedious, and the one-off everyday job. And so let's talk about tedious. Tricky tedious. The tedious is when you've got to repeat production runs. If you're doing that type of work and you've got to make 50 parts or 100 parts every couple of months, well, the CNC clearly reigns in that type of work, and you've really got to get a CNC long term. I'm convinced of that. Tricky is another application where it's a complicated shape. If it's a milling machine, it's a 3D shape. If it's a lathe, it's got multiple radius curves. And it's just really tricky to do on a manual lathe. And CNC reigns again there. You really do need a CNC for that type of work. Complex curves and shapes. But the one-off kind of shop jobs, you know, you're just turning up one part, I've always been of the mind that a manual lathe reigns there. If it's got multiple offset DRO and a quick change tool posts and a digital scale on the tailstock, I've always been of the view that the manual lathe is better for that type of work, and that every shop should have a small manual lathe. But I might be wrong, and there may be one or two of you out there who only has a CNC lathe, and you do that one-off work on it, and And if so, please send me a comment. Well, I've just got to duck out and take this bunch of arbors down to the courier depot, and they're going to Auckland for heat treatment. You know, I've just been thinking about how my opinions shifted about the need for a CNC lathe. You know, I used to think that a modern manual lathe was all you needed, that turning is essentially a 2.5D process, and you don't need CNC control. And then I began to see the advantages of it for a repetitive production situation. And then I began to see the advantages of it for complicated curved parts. And now I'm starting to then I started thinking, well, okay, you've got to have a manual lathe and a CNC lathe, but there's still work that a manual lathe can do better than a CNC lathe, but just more quick to set up, you know. And now I'm starting to think, well, maybe there's shops out there that actually only have a CNC lathe, and I would like to hear from someone with that point of view. But that might not be objective either, because if you just bought a CNC lathe, you wouldn't be able to compare. So what I really need to hear from is someone that's got a full manual lathe and a full CNC lathe, and they're equally proficient at using either of those machines. And have they got to the stage now where they never get a job in that's better done on a manual lathe, and every job is better done on a CNC lathe, even though they've got a manual lathe and they know how to use it? That would be interesting to hear. I'm trying to be objective here. So give me a comment or a post if that's your situation. Cheers. Well, the temperature's dropping fast outside. I'm going to get upstairs and warm up by the wood burner. We could be below 0 tonight. Thanks for watching, guys.